Couldn't stay away, could you? All right, now we're going to go ahead and take a look at quadratics in vertex form. So here, go ahead and copy down this information. You'll notice it looks very similar to what we did in standard form, but a few things have changed. They've actually become easier. So go ahead and copy it down. I'll wait. Okay, let's go ahead and move on then. So a quadratic function is said to be in standard form when it is of the form y equals a times x minus h squared plus k. For those of you who did your transformation posters on the quadratic form, you'll go ahead and realize that this looks very, very familiar to a lot of the things that you discussed. What I want to highlight for you here is this is x minus h. Therefore, whatever this is, we have to go ahead and change the sign. So if I were identifying this, I would say that a equals 1/2, h equals positive 2, and finally k equals negative 1. So now I go ahead and answer these questions. Now you'll notice a behaves exactly the same. If a is greater than 0, it opens up. If it's less than 0, it opens down. So this function, since a is 1/2, will open up. So I know that in general, my function will look like that. From here, I can see that it has a minimum. Now the axis of symmetry could not be easier. It's simply x equals h, or in this case, x equals 2. The vertex, just about as easy as the axis of symmetry. It's going to go ahead, I know the x value is 2, and the k value is going to be negative 1. Now think about why this works. If I go ahead and plug in 2 here, 2 minus 2 is 0. Everything over here disappears, and I'm left with negative 1. So again, it's 2, negative 1. Now in exchange for getting these two easier, it's a little bit more complicated to find the y-intercept. I'll actually have to go ahead and evaluate the function when x equals 0. So if I do that work here, I end up with 1/2 of 0 minus 2 squared minus 1. Order of operations, 0 minus 2 is negative 2. Negative 2 squared is 4. Half of 4 is 2. 2 minus 1 is 1. So I know here that my y-intercept is going to be the point 0, 1. Okay? The max or min of k at x equals h, again, since this function opens up, we know it has a minimum, and the minimum is going to be of negative 1 at x equals 2. So again, what the value is and where it occurs. As I stated before, the domain for this function will always be all real numbers. The range will be an element of all real numbers, but here, since this function opens up and it has a minimum value, I know that y cannot go below the minimum, so it'll always be greater than or equal to whatever that minimum value is. So there's my domain and my range. Now I can go ahead and quickly graph this. Again, same exact order. I'll say here that my axis of symmetry occurs at x equals 2. So there's my axis of symmetry. My vertex is the point 2, negative 1. So there's my vertex. I know that my y-intercept is at the point 0, 1. And if I reflect that symmetrically, it's 2 spaces to the left. I'll have to go ahead and put 2 spaces to the right. Now I've got a pretty good idea of what my parabola looks like. All right, so again, that's how we go ahead and graph vertex form. Go ahead and complete that assignment and make sure that you are proficient in both standard and vertex form, because you never know what's going to pop up on Monday. Have a good one.